Okay, let's see if it's stable. Well, is it as stable as your president? We'll find out.
2 for 52.
Very stable.
Yeah.
How much is what?
All right. So which one again? Sorry.
Term section 3.2, number 41. It's always the read that I just not.
It might be, but you never know. It might be the way they word it. You never know. Right. Oh, okay. Okay. So let's talk about two things that lead up into this. There's the idea of independent. Independent. I like it. Independent. I like the word banana. If A and B are independent, what does that mean?
They don't change. They don't change each other?
So help me out. What do you check mathematically to see if A and B are independent? You check what? Probability of
A given B.
A given B has to equal
A.
probability of A. Yeah, the probability of A, if it doesn't change, even if I know that B happened, then obviously they are something I'd call independent. One didn't give a shit that the other one happened. So I would call that independent. So if they tell you two things are independent, you immediately write this down. So if they said C and L are independent events, then I would write for myself probability C given L equals the probability of C, for example, right? Or the other way around even. Probability of L given C has to equal what?
L.
Probability of L. So L can't change C, C can't change L. So that's awesome. So it's if they say these two events are independent, they've just told you something mathematically that might come into play, that will obviously come into play in their questions. And you write that down for yourself. That's a fact. You're translating from English to Mathish, right? Now what about, so is that decent? So now, J and K are independent events. So what does that mean you can write? If J and K are independent, what can you write down? Probability of J given K equals probability of J. Now that problem is really easy now. I have no qualms saying what I just said. As a math teacher, you got to be careful to say that. That's a situation where I'm like, yeah, that's easy. Now what about the other possibility? They can say they're independent, or they can say that they are mutually exclusive. I like how they say that. Mutually exclusive. So what does that mean mathematically? What's mutually exclusive mean?
They affect each other.
Yeah, but stay away from that. That's kind of like bringing this idea in, and then mutually exclusive is its own idea. What does it mean to be exclusive? What's the first thing that comes to mind when you think of exclusive?
Together.
They stay together.
Say again?
They stay together.
Is an exclusive restaurant means what? They're not going to let me in, right? So exclusive means somehow that they exclude certain people or certain groups or certain whatever. You with me? Exclusive. It's exclusive. Only if you're a member of Delta Premier can you go into this lounge. I'm like, I don't want to be in there anyway. All right, you with me? Don't flight Delta. So that's exclusive. Mutually means they both do that thing to each other. They mutually exclude each other. You can't be over here. Well, you can't be over here. So what does that mean physically? Are the events Democrat and woman, are they mutually exclusive? No. Because you can have a person that is both. So there is an overlap. Now, I used to do cat and dog, and then there was this crazy-ass cartoon that was a cat dog, yeah, and then you don't think too much about the biology of things. So now I'm just doing like rock and ice cream, right? Are they mutually exclusive? Is there anything that can be both? You can have ice cream that looks like a rock, but is it a freaking rock? No. You can have rock that looks like ice cream. You can eat that shit, right? You can lick it. I wouldn't recommend it. It's It's not going to be the same experience, right? So those are mutually exclusive because if you are one, you cannot be the other one. So if I tell you that A and B are mutually exclusive, what does that mean mathematically? No. All right. I love you guys. I try desperately to keep these two ideas separate. If you are mutually exclusive, you are the most dependent you can be. So if I go into a room, oh, you're gonna love this example. Just stay with me. If there were like 10 bowls with rocks in it and 10 bowls with ice cream in it in a room, and I go in blindfolded and I pick up a bowl, what's the probability I picked up a bowl of ice cream? 50%, right? 10 out of 20, right? Half of them are ice cream, so there's a 50% chance I just picked up ice cream. And then that's rocks. Shit. So given that it's rocks, what's the probability it's ice cream now? Zero. Oh, shit. So if you're mutually exclusive, you're the most dependent you can be, because if you're one of them, then the other one has no chance of happening. Whatever the probability was, it is now zero. There's no chance of them being the both, right? So if you are one of them, you can't be the other one. That's the most dependent you can be. Now, please, dear God, drop the idea of mixing these two ideas. Stop it. So what's this mean mathematically? The probability of A and B is? And what's on the top of this formula? What's in the top of the given formula? This. So this will always equal 0. It won't equal what this was. That's why they're kind of like not what you think at first. Okay. So, please, dear God, we just discussed some high-level shit. All you really got to worry about is in some problems they will say L and W are mutually exclusive. So what can you immediately write down? Probability of L and W equals 0. And anywhere you need it, you use it. You know that's a fact. Or they're going to say this, and you can write this down. Anywhere you need it, you can use it. Bam. Yes, sir?
Is it possible for data to be neither one of those?
Of course.
Okay.
Totally. It's sort of like being perpendicular and parallel. Do you have to be one of the two? No, you can meet, just not at a 90-degree angle. It's the same idea. These are kind of like two extremes. Yes?
Okay, so mutually equals 0, independent, it has to equal one of them? Or like,
So mutually means they can't occur at the same time.
yeah.
Independent means if one happens, it does not change the other one. Yeah. So the probability of A given that B happened is the same as A was by itself before. Knowing more about it, knowing this, doesn't change the probability of that. Yes, sir?
Before the quiz, will you explain like the formulas and what we need to know like for tomorrow?
Oh, yeah, can we have a formula sheet?
Write it all
We're going to have a
down?
formula sheet, yes. Yeah. Let's do that right now. Let's make a formula sheet up. Then maybe that'll spur some more questions. Okay.
I don't understand.
What's this?
Probability of A or B.
True. What's the formula?
Probability of A.
Probability of A plus-
Probability of A and B.
Yeah, you add the two together.
Oh, thank God we can have that.
What's the formula? I can,
Yeah.
goes on the old formula sheet. Makes sense. So if they were mutually exclusive, this formula doesn't actually change, but what would this be if they're mutually exclusive? This would be
0.
Zero.
The formula is still the same. The book sometimes makes it sound like the formula changes. No, it's still the same formula. It's just that that's a 0. What about probability of A and B?
Probability of A given B.
Yeah, sorry, I'm thinking ahead of myself. Probability of A given B times.
Probability.
Probability.
In fact, let's write it like this. It's a little bit more like what we do with situations I give you that you can just write, probably get a red one given that you got a blue one. Probably B times probably A given B. Or the probability of A times probability of B given A. Either way. They're both the same value. This is like picking a red first and then a blue second. This probability might change if it's without replacement. That's what this says. Now, if they're independent events, if A and B are independent, what does this equal? No.
The same thing.
Yeah, it equals the probability of A. That's the one time you can take two probabilities and multiply them together to get the and, is if I know that they are independent. Otherwise, you're not allowed to do that shit. You have to calculate the given for the second time. Okay. If you look back at what we did yesterday, when I did it with replacement, and I said, let's probably get a red one and then a blue one or whatever, I just multiply the two probabilities of those things together. Because when I do it with replacement, I know that they are independent. If they're not independent, what happened to this? It changed. Right? At least the bottom changed. If I threw out a chip, the bottom has to change. Okay. Oh, you guys look so excited. All right. Okay. And actually, this formula came from this one, but I like this kind of progression anyway. Probability of A given B.
Probability of A and B over B. Probability
Yeah.
of B.
So the given is on the bottom. I like it. Any other formulas you think you should have up there?
Probability of A and B equals 0.
No, it's not a formula. It's an idea. You could write it down if it's always true. And it's not always true.
Is there a formula for that ring problem?
For the...
With the mass of rings?
Oh, the rings. That was the idea that led us to believing that and is multiplication. So that's this. Yeah. I like it. I better not see any probability A given B equals probability of A if independent. Oh my God. No, that's an idea,
Just that.
not a formula. You can say, but there's an equal sign, Jeff. I don't give a shit. That's an idea,
Oh my
not a
God.
formula.
Probability of
That's
probability
all
we can put.
Yeah.
minus probability, right?
That's, yeah, I like that. But don't put that down here. That's an idea.
Well, I just did.
That's an equation.
I can put.
I don't care.
I can
That's
put,
an equation I won't let you put up here.
I can put probability of B.
Just like the
given
class
A.
with equation, I didn't let you put that down. Yeah.
I can put probability of B given A. It's just the
Sure,
opposite.
sure,
Okay.
sure. If you want to, probability of B given A. Because what's
Probability.
interesting is,
Probability of A and B over
yeah,
probability
good.
of
B and A is the same as A and B,
A over probability of A.
but now it's the A on the bottom.
Okay.
Is this really a different formula?
No, it's the
No.
same one, but
Same one.
it's just comfort.
Now don't put this on your formula sheet, okay? I'll put it on a different board. If I ask you to figure out probability of S given W, and it's in the middle of some problem, what would the formula for that be?
Probability of S and W over probability of W.
Yeah, the idea of it. The formula captures an idea. The A and B don't mean shit. They're just variables. Why are they A and B? Because we started at the beginning of the alphabet. Could they be S and W? Of course.
Yeah.
So some of you guys doing their homework, there's like C's and L's, and California and Latino, there's a problem that refers to those groups, and there's another later problem that refers to opponents and supporters of same-sex marriage, right? Yes.
Can you give an example of numbers for that? Of numbers?
Let's do this. Let's look at one of these problems I was just talking about, because I know, even if nobody has a question about it, you should, and you probably do. You just don't feel like asking for some crazy reason. So let's go over this. There's two of them that look like this one. I'm going to look at specifically. So there's. I'm freeze. This one here, And then there's another one later that's the same-sex marriage kind of thing. Okay? The very first thing, see how they define C to be California's preferring life in prison over the death penalty, and L is Latino Californians, right? So they define those letters. So using those letters, before you even look at the questions, I'm trying to give you an idea how to attack a problem like this. 48%, can you write a symbol using those letters? That is what 48% is. 48% of all Californians registered voters prefer life in prison without parole. So what is equal to 48%? Probability of what? Probability C. That was pretty simple, right? I guess. But if you tell yourself what that is, when you write formulas, you know what to put where. It's just like in algebra when you had to identify, well, that's D and that's X, and now I know where to plug this shit. You have to tell yourself what the values, what variables they relate to, so you put them in the right place. So for this problem, let's see, I can write in my own book. This is not a book, Jeff, it's on the computer. Shit. So this would be P of C equals 0.48. And what's the other percentage they give us? There's a couple of them, right? Among Latino California registered voters, and I warned you about this, that the book will not use a certain word all the time. Among Latino California registered voters. What's another way to say that using a word that's more related to what we've done? Given. What does given mean? I focus on a smaller group. That's what among means. So given what? Among. Given what? Don't tell me number. Given.
California registered.
No.
Latino.
Latino California. So given L. Given L. 55% prefer life rather than that. So the C given L. That's equal to what? Now say the number. 55%, 0.55. Oh. Say again? No. I don't even know what the questions are doing. Do I have the questions showing?
No.
I am telling myself, I'm translating from English to Mathish what they're telling me. Why does that help me? Because the formulas aren't in English. They're in Mathish. So I need to kind of bridge the gap. There's one last percentage they give me, and what's that relate to? P of L. L. Yeah. Okay. 0.376. Now, what is the first question they ask you?
Probability of C.
Oh, look at this shit. Probably C. We know. See? You can be nice to yourself. Probably C we know. Probability of L we know. Probably C given L we know. So the first three we already know. Sweet. No. And the 47 is just in words. What is that? Okay. You should be able to do that. How do I find the probability of L and C?
Probability of C times probability of L.
Yeah.
Given C.
L and C would be either probability of C times the probability of L given C. Do I have L given C? I really want you guys to get this. So again, all right, really. So here is the first question they're asking me that is not something they just told me. I have to use a formula. So you write the formula down for and. So what is the formula for L and C?
Probability of
It could either be
C.
probability of L times probability of C given L, or it could be probability of C times probability of L given C. Well, I know C given L, so screw this one. Don't I know probability of L?
Yeah.
Yes. Don't I know probability of C given L? Yes. Hey. So it's matching what they tell you with what they ask you. That is actually what some of algebra is all about. Hopeful. What happens? Is everybody cool with these three things? How we got that from the write-up? Okay. When they ask you a question that is not something they just told you, what do? You write the formula down for it. Here, there's a couple of options for what the formula could be. I use the one that has the stuff that I know. Right? So you write the symbols directly for what they tell you. And when they ask you a question, you write the formula that would be the answer to that question. You just see, do I know the stuff for the formula? And you plug it in. What's going on? You guys? Anybody have a question? I can't just interpret your face. Yes?
What number is that?
48. Yeah. Yes.
We do 86D.
Is that the other one that's like this? 86. Oh, this one, okay. So if I roll two fair dice, and you got normal die, right? Not Dungeons and Dragons, kind of 20-sided die or something, right? Normal 6-sided die. Sample space. What the shit is a sample space?
All the possible outcomes.
All the possible outcomes. I love it. So what's one possible? If I roll two dice, what's the possible outcome for those?
36.
Not how many. Not what the probability of each one is. Not how many. Give me one possible outcome. 1-1. They could both. The snake eyes, right? Could both be ones. Or it could be a 1 and a 2, or a 1 and a 3 and a 1. Or the first one could be a 2, and the second one could be a 1, or a 2 and a 2, or a 2 and a 3. I mean, come on. All the possibilities for the outcomes. And what's an outcome? Two numbers. What's the number on the first die? What's the number on the second die? So, what could be the number on the first die? 1. Second die, 1. 1, 2. 1, 3. Blah, blah, blah. 2, 1. Blah, blah, blah. 3, 1. Blah, blah, blah. So yeah, part A wants you to list them all out. How many will there be? 36. Why 36? Because there's how many options for the first one?
6.
And for each of those, there's how many options for the second one?
6.
6 times 6? 36. So that's how many there's going to be in your sample space. So if that's too much work, right, so you write it all down for yourself. Trust me, because that will help you answer the questions afterwards. Because then you can just count how many things match what they're asking me for. Now your question was D or E? D. A is the event that a 3 or a 4 is rolled first, followed by an even number. So it could be like 3, 2, 3, 4, so forth, right? And B is the sum of the two rolls is at most 7. So it could be like 3, 4, 2, 5, 2, 2, 2, 3. You know, it's at most 7. Then maybe some of you guys see, if you write it all down for yourself, you can then just count what you need to answer the probability questions. Yes?
Are we just answering them like that?
Well, the first question was just list all the outcomes. Now you can start doing probabilities, because now you can just see everything that could happen. Yeah, and I just got to count how many things match what you're looking for.
The first part of that would be what, 12 out of 36 then?
I don't know. That'll be up to you.
No,
With this,
for that, if it's assuming, just make sure I got the right idea. So assuming that, saying like 3 or 4 is rolled first, you have all the 3s and all the 4s.
75.
no. You're given that B. You're given that the sum is MO7.
That's rolling.
Given B.
It's right here.
Is that what you're asking?
75% say the rolling is important to
That's
them.
what that question was.
It's right here.
Wait, no, I'm looking
75 say
at
the
B.
rolling
That's
is
not the answer.
Why?
It's 0.6.
So if you're asking how to do part B.
Yes, well, so for the 3 and the 4 together, that'd be what, 12 out of 36?
Yeah, well, you have to count how many have a 3 or 4
Okay.
first,
Why
followed
is it
by an even number.
60%?
Yep. So, I don't know what's happening. So, how many things can have a 3 first? Like 3, 1, 3, 2, 3, 3, right? So for part B, what's going to be on the bottom? How many total things could happen? We already said it earlier.
Oh, okay.
36.
I get it.
then you just have to count
6
how
and
many
10.
match having a 3 or a 4
I
first,
had that earlier.
followed by an even number. And why is it going to be easy? Because you're going to have already listed everything that could happen. You just got to count. Well, there's one, 3, 2. 3, 4 would be another one. Just got to count how many match what you're looking for divided by 36. The idea of probability doesn't change. Yeah, I'm getting there. All right. I'm trying to. So in part D, there's a lot of different ways to say this in English. You can say it very directly. This is the probability that given that. Just replace P, probability that. Replace A with the English phrase. Replace the line with the word given. And replace B with the English phrase. Right? So in algebra, X represents a number. In probability, A represents an outcome, right? It represents an English phrase, right? So how do I translate this in English? I just replace all these with what phrases they represent. What does P parenthesis mean? Probability that, that's what that is in English. What's A in English? They tell you. What's the line in English? Given. What's B in English? They tell you. Please let that one be easy. Okay. I love you guys. If you haven't really tried that one yet, you have no right to give me any look on your face at all. Yeah. You have to try it first, right? Okay. Any other questions from homework? Yes.
Wait, on B, what would the numerator be?
That would be all the A's that are in the B's. So what I would do if I were you is I would circle everything that matches B, and that's my universe. Or you might even write them by themselves. Right? Pick everything that matches what B is, because that's given B. Write them by themselves. That would be your denominator. How many? And then out of those, just count the ones that match what A wants to have. That'll be the top, of course. Right?
For C,
51. Whoa, shit.
Probability of C.
Where am I? I'm in chapter 2 now.
California registered voters who support
61
gay
times
marriage.
78.
No, it's just number. Support same-sex marriage given that they are registered voters.
Okay, so
18 to
probability of
39
C.
years old.
So
All right,
61.
51.
18 to 39 years old.
Oh,
California
okay.
registered voters.
This one? The L or C?
So they're 18.
You write
30
the
years
formula.
old, and they're California.
What's the
registered
formula
voters.
for probability of L or C? What's the formula for the probability of L or C?
You don't have to do the formula?
No, it's right here.
Yeah, the probability of L,
What do you do for
which
D?
we know,
D,
plus the probability of C, which we know,
Oh, it tells us that.
minus
I
the
did it
probability of
for
L
formula.
and C,
Can't work
which
it
you
out.
figured out. Yep. So again, when they ask you a question, you write the formula for it, and you step back and you say, do I have everything I need? If you do, plug it in, get it. If you don't, how do I get what I need from what they told me? So when they ask you a question, you write the formula that goes with it. They ask you a question, you write the formula that goes with it, and then you go, do I know all this shit? If you do, plug it in. You're done. If you don't, how do I get what I need from what they told me? Again, that's a very, what do you guys had for algebra? That's a very algebraic idea of writing another formula for what you need and then figuring out what goes where. Anything else from homework stuff? Yes. Oh, this is the other one. This is the one, yeah. So again, the first 4, I'll give you this clue. The first 4 questions, I think it's the first 4,
Yeah.
all come directly from the write-up. When you see language like among or out of, that's given. Because you're focusing on a subgroup. That's the given. So the first 4 questions relate to the 4 things they tell you.
For G,
Yeah.
You just have to take a minute. Before you even look at these, you should use the symbols they use, and just like we did a minute ago, write the numbers they give you in the symbol that represents that idea.
Was it rather if it's like 8 to 39 years old or 6 to 7 California registered?
Well, I mean, mean, the 18 to 39 tells you which event you're dealing with. And the 6 and 10 is just another way to say 60%. Yeah. All right, you guys look appropriately excited. I mean, not. Okay. You just got to try these out. My God. Yes, and you do have to extend yourself a bit. You have to think. Yes. I know it hurts. It's good for you. Just like your muscles are aching after workout. Same thing. It means good things. Normal.
Do you have 45%?
Anything else
45.
about from the homework stuff?
43, 3.1.
And 3.2?
Oh, okay. Ooh, I like it.
3.2 I meant.
It doesn't matter. Still 43. You guys never have to tell me the section because it's one big blob of homework. Q and R are independent events. I don't care what the hell else it says. What can I write down right away?
Probability of you
Get a
given
little more
V.
specific to the idea of independence.
Probability of V. You given V equals U.
Q and R.
Oh,
You're talking about number 43, right?
Probability of Q given R equals probability of Q.
Probability of Q given R equals the probability of Q. And the probability of R given Q equals the probability of R. Right? It doesn't change. Given the one thing, the other guy doesn't care.
45.
You can write down both of those things. And now you can answer
For G.
the question.
Just
Now this is interesting.
watch better.
They give you the probability of Q, they give you the probability of Q and R, and they ask you for the probability of R. Now which one of these has a formula associated with it?
Q and R.
Q and R. Write the formula for it, see what they gave you, and then plug in what you know. So what is the formula for Q and R? What is that formula?
Probability of
Q times probability of Q given R.
No?
probability of R given the probability of
Yeah. You got to multiply one by the other one.
Yeah.
Yeah. But what did we just say is true about probability of R given Q? Since they're
N
independent,
equals probability of
it's
R.
the same thing as what the probability of R is anyway. And don't you know the probability of Q? And you know the probability of Q and R? Can't you solve for the probability of Q then? Or the probability of R? I forgot, I lost you. Plug in what you know. I love you guys. This is algebra shit. Right? You're at 160, 110 should be easier. What's this? Do I know what this is?
101.
I know what it is. Do I know what this is?
0.4.
I know what it is. Do I know what this is? I know it's R.
0.1.
Can I solve for this? Yes, because I know these two things. I can solve for probability of R because I know this and I know this. It's just a little equation to solve.
Isn't it just probability of R?
Huh?
Isn't that just probability of R?
Yes.
Okay.
This? Yes.
Yeah. Okay.
Yes.
So you should do probability of Q times probability of R.
We don't know what the probability of R is. That's what we're trying to figure out.
No, she's saying right here, it's probability of
No,
Q.
no, no. I got you.
Yeah. So I know what this is. I know what this is. Times I don't know. I can solve for I don't know. That's what algebra taught you. Hopefully. So if this was 10 and this was 3, how do I solve for this? I divide. Right? That's it. How do I solve for this? I divide. Okay. I love you guys. You just plug in what you know into the equation and solve for what you don't know. That's it. That's all. Don't overthink this.
That's 25%.
Okay. Anything else from the homework stuff? Okay. All right. Anybody else still need the copy of the probability thing from yesterday?
What did you get for R?
Oh my god, 0.7525.
Anybody else need that copy of the probability thing from yesterday? Why don't you guys take a minute? I know some of you guys have done the practice one on the back.
And that's 45.7 if I remember.
Why don't you guys take a few minutes,
Yeah.
compare with other people around you? If you haven't tried these out, maybe give them a quick look. I'll give you like 10 minutes and then I'll give you the answer key for
What
it.
is it equal? 36?
What?